single craft if it is guessed correctly as such. However, the experience reveals that the attackers and traffickers will seek shelter in the clusters, so individual tracks provide very little information on the exact intent. I'll emphasize the word exact intent of such attack craft. Further, the analysis of collection of tracks for a certain amount of time may provide some information, but clearly depends upon the degree of attention and level of fatigue of the user. Now, let me move on to methodology. Our methodology is fundamentally based on representation of fishing craft cluster, including possible illegal craft as a dynamic swarm model. And we make predictions on the intent of possible attack craft by monitoring the deviations from the overall swarm behavior characteristics by an illegal craft. Can a fishing cluster be modeled as a swarm? The answer is yes, because they have to have coordinated navigation and resource sharing behavior. Here, they have to maintain the swarm behavior, not too far going into unknown waters, not too close also due to resource sharing constraints, and almost synchronized movements with the cluster. Further, we make a fair assumption during the modeling, the interaction with the craft in front is stronger than that with those behind due to obvious navigational requirements at dark hours. Proposed model. This is well explained in detail and proofs in the paper. So here I will go into non-mathematical explanation and I will explain how we can make use of this model to derive deductions using next few slides. Now let me focus on to the real problem. How to detect an illegal craft. Here I will make use of two parameters. First, I'll define something called the virtual attraction force between each craft of the cluster, which are marked in dotted lines. Secondly, I will define a term called directional sensitivity, which is an indication of the correlation of bearing of any craft with the general direction of the cluster. Okay, having defined that, let's make following propositions. If an illegal craft is considered, the attraction force with the center of the cluster should be lesser with respect to the average value of the same considered with other crafts of the cluster. First proposition. Second is the directional sensitivity of a particular craft is higher than that of the average of the predetermined sensitivity of the cluster, and it bias outwards the general direction of the center of the cluster. If it is, it can be considered as an illegal craft. Intuitive enough, isn't it? It is similar to say in simple terms, if the bonding and goals of someone is different from that of a group, he may not belong to that group. Expected outcomes. Now, I will draw the deductions out of the proposed model. Outcome 1. For any ith craft, let's say any craft I, if virtual attraction force is below the threshold and the directional sensitivity is above the threshold, it could be determined that ith craft is not collaborating with the cluster. First outcome. Second outcome is again an extension of the first outcome. I take another craft as Q. If it fulfills the same conditions, it is also not collaborating with the cluster. Now we have two craft. We have detected not collaborating with the cluster. Now out of these two outcomes, I will deduce the third deduction, which is more interesting and more behavioral. Outcome 3 is, if now we have two craft, we keep on monitoring these two craft. Let's say if the ith craft, the first craft I quoted, is below the threshold, but the second craft is keeping the threshold with the next time instances. We can deduce that the ith craft is commanded to move towards the qth craft, that is the leader-follower behavior. So there's a swarm is forming within the cluster. So this is sort of maybe you find new, but this is deviating from the conventional radar detection methodology of having a target or not. This research emphasizes to incorporate behavioral aspects into the methodology. With those conclusions, let me wind up touching on future research. Definitely, we have to fine-tune this model, and with the sufficient quantitative observations of fishing clusters. And at this backdrop, I want to emphasize the requirement of customization of sensor capabilities as per target characteristics. With this, I will complete my presentation and would be delighted to accept your comments, questions, and clarifications should there be any. Thank you.